FAZRINA binti Sarah KAMAL with student ID 2024427516.
Hi, my name is NURUL binti ABDUL HALIM and my student ID number is 2024429546.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is FIKRIYah BATRISYIA binti FAIROS. My student ID number is 2024208578.
Hello, my name is ZULAIKHA and my student ID is 2024215666.
Good day everyone! Today, our group will present on electromagnetism in transportation, which is maglev trains and hybrid cars. These two technologies show how electricity and magnetism play major roles in modern mobility. Electromagnetism is crucial in transportation systems because it enables propulsion, levitation, braking, and power conversion. Maglev trains rely on magnetic levitation and electromagnetic propulsion, while hybrid cars depend on electric motors and regenerative braking. Electromagnetism began with Ørsted's discovery in 1820, followed by Faraday's induction principle. Maglev technology was first tested in 1960s and the first mass-market hybrid car, the Toyota Prius, was released in 1997. Both technology address modern challenges such as reducing emission, improving efficiency, and increasing mobility. They use key physics concepts like magnetic field, induction, and the Lorentz force. So, in today's presentation, we will explore about maglev trains and hybrid cars by looking at their electromagnetic principles, real-world applications, and future development. To begin with our first major technology, which is maglev trains, I will now pass the presentation to Dania, who will explain about how magnetic force allow these trains to levitate and achieve extremely high speeds.
So, what are those electromagnetic concepts behind maglev trains? Maglev trains use powerful electromagnets to float and move the train without wheels. It uses such as magnetic levitation. What is magnetic levitation? Magnetic levitation is a magnet on the train and the guideway interact so that like pole repel and opposite pole retracts. This lifts the train off the track and hold it steady above the guideway. There are two main systems such as electromagnetic suspension (EMS) and electrodynamic suspension (EDS). What are EMS or electromagnetic suspension? Electromagnetic suspension is electromagnets on the train are attracted to magnets in the guideway to lift and guide the train, while EDS or electrodynamic suspension is superconducting magnets create repulsive magnetic force with the guideway so the train floats higher. Lastly, there are propulsion. What is propulsion? Propulsion is coils in the guideway powered by alternating current change polarity to pull and push the train forward using magnetic force. In short, maglev trains float on magnets, which is repelling or attracting, and are propelled by changing magnetic fields, eliminating wheel-rail contact and allowing high-speed travel. Next, we move to global example of maglev train. The best global maglev example is the Shanghai maglev train, which is China. The world's first commercial high-speed maglev connecting Pudong Airport to the city at 431 km per hour since 2004. Alongside Japan's Chuo Shinkansen under construction, world record speeds in testing, and South Korea Incheon's airport maglev, which is lower speed and urban use. This showcases that maglev used for airport links such as Shanghai and Incheon and intercity travel such as Japan's future line, highlighting speed, reduced friction, and technological advancement. Compared to conventional railways, maglev trains have a higher top speed, superior acceleration and deceleration, lower maintenance costs, improved gradient handling, and lower noise. However, they are more expensive to build, cannot use existing infrastructure, and use more energy at high speed.
Alright, now that we understand how maglev trains float and move, let's switch over to hybrid cars. Rose will take over and explain how their electric motors and braking systems use electromagnetism.
First, I'll explain about what are hybrid cars. Hybrid cars are vehicles that use two power sources, a petrol engine and an electric motor. At low speeds, the electric motor reduces fuel consumption and emissions. When more power is needed, the petrol engine takes over. This combination makes hybrids more efficient and environmentally friendly than normal cars. Next, I'll talk about electromagnetic concepts in hybrid cars. Hybrid cars rely on electromagnetism to run their electric motors. When electricity flows through coils inside the motor, magnetic fields are created, causing the rotor to spin. This spinning motion moves the car. Hybrid cars also use regenerative braking. When the car slows down, the motor becomes a generator and converts movement into electrical energy, which is stored in the battery. This allows the car to recover energy that would otherwise be wasted. Inverters and converters helps regulate the electrical current, making sure the motor and battery work smoothly together. Now, I will expose the types of hybrid cars. There are four main types. First, battery electric vehicle (BEV). Fully electric, no petrol engine, must be charged externally. Next, hybrid electric vehicle (HEV). Uses both petrol and electric power, charges through regenerative braking. Other than that, plug-in hybrid electric vehicle (PHEV) can be plugged in and can drive moderate distances on electricity alone. Lastly, fuel cell electric vehicle (FCEV) uses hydrogen to generate electricity, releasing only water vapor. Moving on, I will talk about the real-world implementations. Here are real examples of each type. For BEV, Nissan Leaf, fully electric with zero tailpipe emissions. For HEV, Toyota Prius, automatically switches between petrol and electric power. For PHEV, Volvo XC90 Recharge can run on electricity alone for short trips. For FCEV, Toyota Mirai, powered by hydrogen fuel cells with only water emitted. Lastly, I will explain about the benefits and challenges of hybrid cars. The benefits are: first, improved fuel efficiency as energy use is shared between the engine and motor. Then, reduce emissions, helping lower environmental impact. Lastly, regenerative braking, which captures energy and increases overall efficiency. On the other hand, the challenges are higher purchase costs since hybrid systems are more complex. Other than that, expensive battery replacement, although not frequent. Last but not least, more complicated maintenance due to having both an engine and an electric system.
Now that we know how hybrid cars work, let's look at what this means for the future of transportation. Zulaikha will explain the comparison and what's coming next.
Comparison between maglev train and hybrid cars are: for technology use, maglev trains use magnetic levitation technology, allowing the train to float above the track and greatly reduce friction, while hybrid cars use a petrol engine and an electric motor, switching between both to save fuel and improve efficiency. In terms of speed, maglev trains are extremely fast, reaching 500 to 600 km per hour, while hybrid cars travel at normal road speeds of 120 to 180 km per hour because they are meant for daily use. In energy efficiency, maglev trains are efficient due to low friction but still require a large amount of electricity. Hybrid cars are also efficient, especially at low speeds, because they can run on the electric motor and use petrol only when needed. The purpose of each system differs as well, which is maglev trains serve public transportation for fast travel between cities, while hybrid cars are designed for personal transportation, offering convenience for everyday travel. Future development. Maglev trains are expected to become faster and more energy efficient in the future. Countries like Japan and China are developing next-generation maglev systems that may exceed 600 km per hour while using less power. Future improvements will likely focus on lowering construction costs through cheaper magnetic materials and modular drives. Maglev systems may also be integrated into smart transport networks for real-time control, automation, and better safety. Researchers are even exploring superconducting maglev technology, which uses low-resistance magnets to increase efficiency. Overall, the future of maglev aims for higher speed, lower cost, and a more sustainable, fully automated transport system. Hybrid cars are expected to become more advanced with better batteries, improved fuel efficiency, and greater environmental sustainability. Future hybrids may use solid-state batteries, which last longer, charge faster, and are safer than today's lithium-ion batteries. Manufacturers are also developing engines with lower emissions and smoother transitions between electric and petrol power. Many upcoming models may be plug-in hybrids, allowing drivers to charge at home and travel longer distance on electricity alone. Smart features such as AI assist driving, stronger regenerative braking, and more aerodynamic designs will further improve efficiency. Overall, hybrid cars will continue to become cleaner, smarter, and more energy efficient as technology progresses. Over conclusion, maglev trains and hybrid cars show how the transportation and automotive industries are moving toward cleaner and smarter technology. Maglev trains provide extremely fast, energy-efficient public transport, while hybrid cars offer more efficient and environmentally friendly personal travel. Although they serve different purposes, but both technologies highlight the industry's shift toward sustainability, better performance, and advanced innovation for the future.
And this is the reference for our presentation. That's all from us. Thank you for watching.